So yes, hello Ashish. First of all, I would like you to welcome to the platform of MargDarshan and especially in Abhiyan batch. आज हमारे साथ में केतन सर है, currently working in HPCL as a civil engineering in civil engineering basically. So today he is going to take your mock interviews for BHEL interviews. So yes, please carry on, sir.
Okay, so Ashish, could you please tell me a brief about your academic background?
Uh, Sir, I did my integrated BTech plus MTech from IIT Kanpur in civil engineering. It was
Okay,
reduction in air pollution by
okay,
replacing LPG stove with induction.
okay. What was your MTech project?
Reduction in air pollution by replacing LPG stoves with induction stoves.
Okay, you have told about these two terms, LPG and induction stoves. What is the basic difference between these two, and how do they pollute the environment?
Sir, basically, for LPG stoves, we have a pre-notion that it is a very uh, LPG burning LPG fuel also produces a lot of particulate matter, uh, some of NO2 also, and carbon dioxide. Along with that, it also produces benzene and toluene too. So that is harmful for whether though it is in a small, but it is harmful for the cook. And in terms of induction stove, it's almost negligible air pollution on uh, on the cooking side, but it also puts pressure on the thermal power plants as the electricity requirement will be high.
Okay, okay, fine. So you have told the byproducts as benzene. And initially, which gas is present in LPG?
Uh, Sir, I think so propane is one of the constituent of this. I'm not
Okay,
sure about.
propane or butane? Like what is the main source of this benzene? How is this benzene produced?
Uh, Sir, I'm not sure about it, but it produces a bit of concentration of benzene is produced actually.
Okay, okay, fine, no problem. Okay, Ashish, have you heard about doubly reinforced section?
Yes, sir.
So why do we need them?
Uh, Sir, when we design for a particular moment of resistance, uh, sometimes singly reinforced, just giving reinforcement in the tension part does not satisfy this required moment. So we have to either increase the section, or we have to uh, or we have to often give a double post beam.
So why can't we increase the section?
Sir, uh, सर फिर अगर हम सेक्शन इंक्रीज करते जाएंगे तो फर्स्ट ऑफ ऑल इकोनॉमिकल नहीं होगा, और फिर सर वो उसके फ्रैक्चर और क्रैकिंग होने की टेंडेंसी भी बढ़ जाती है.
Okay, okay, fine, good answer. Uh, so doubly reinforced section is also good in earthquake resistant structures. Is it right or not? Like, does it reduce to some extent the cause of earthquakes or not?
Yes, sir. It can register these earthquake forces more uh, more effectively, because in earthquake we get the opposite frequent forces. So if we have reinforcement on both sides, then if the tension side sometimes get the compression, or the compression side gets the tension, the reinforcement can balance these stresses of earthquake.
Yes, yes, very good, very good. This is the answer I was expecting. So this whole process is called as a stress reversal process, and doubly
Yes,
reinforced
stress
sections are,
reversal.
yeah, doubly reinforced sections are very good in that. Okay, okay. What is, tell me the spacing between the lateral ties in a column.
So, sir, spacing between lateral ties uh, depends on the section dimension, uh, dia of main reinforcement, and uh, dia of the lateral ties we are providing, and it cannot be more than 300 mm.
Okay, okay. What is the difference between lateral ties in column and stirrups in beams?
Uh, Sorry, sir, can you repeat the question?
You know about the stirrups in beams,
Yes, sir.
okay, and lateral ties in columns.
Yes,
So,
sir.
what is the basic difference between the stirrups and the lateral ties?
Sir, basically stirrups are provided in the beams to resist the shear produced in the beam due to loading, and the main purpose of providing lateral ties in column is to hold the main reinforcement in the column, so they do not buckle more, and be in place of the place where we wanted to place the reinforcement.
Okay, fine. Okay, you told that stirrups are used to resist against shear. Okay, so is the shear
Yes.
resisted only by stirrups? Is the shear
Sir,
resisted
some of
only
the
by
shear
stirrups?
is registered by sir.
Hmm?
Some of the shear is registered by the concrete also, and because there is the value of maximum shear strength by the column, which depends on the grade of concrete we are using and the percentage of steel we are providing. It is provided in our IS code. So uh, concrete also takes the shear, and in if and we provide stirrups to resist the remaining shear which is acting
In this whole
on the
scenario,
beam.
there is a term called as dowel action. Have you heard it?
Dowel action, yes, sir.
So, could you please briefly elaborate it?
So, sir, dowel action is basically when
Ashish, I'm not able to hear you.
Actually,
Are
some
you
net
there?
actually something network issue happened. He got left. Might be he will be connecting. Okay, give a second.
Okay, okay. Let by dowel action.
dowel action. Yes, sir.
Yeah.
So, sir, dowel basically when we uh, provide the provide the reinforcement, so we have to hook these reinforcements so that if it is tensioned, so they do not get pulled back. So we provide a hook like uh, uh, hooking mm,
So you are telling about
the
anchorage and bend. Is it called as the dowel action? Are you sure?
sir. Yes, I think, sir. I'm not sure actually.
Okay, okay, fine.
I think
Very simple question. What is meant by static indeterminacy?
So, sir, static indeterminacy is the degree, is the number of, basically the number of reduc uh, equations, number of extra equations required to solve the forces in the members. So there are some equilibrium equations. Apart from that, we need some extra equations to solve these forces. So the number
So
of
for
extra forces
okay.
is static.
So for a prop cantilever beam, how many equations do you need?
For a
I repeat my question. For a propped cantilever beam,
prop,
okay.
okay.
So how many equations do you need to solve it?
Uh, so, sir, for propped cantilever beam, uh, we will it will basically depend on the uh, nature of loading. Uh, if it is just the vertical loading, then we will have the mm, three number of uh, there will be only three number of unknowns. But if it is both vertical and horizontal, then there will be four
So
number of
in case of
unknowns.
vertical
So we
loading,
will
in case of vertical loading, what will be the static indeterminacy?
in case of vertical loading, sir, one will be the static indetermination.
I repeat my what will be the
Hello?
static indeterminacy? I repeat my question. What will
Yes,
be
sir.
the static indeterminacy if the loading is inclined?
Then also it will be one.
Okay, fine. Yes, good. Okay, now let's move to some part of fluid mechanics. Uh, what is the basic difference between venturi meter and orifice meter?
So, sir, basically both are used for this uh, calculating flow, but sir, sorry, sir.
Okay, no issues. What is the difference between laminar flow and turbulent flow?
Sir, your voice, क्या sir?
अब what
Sir, आवाज कट गई.
what is the difference between laminar and turbulent flow?
अच्छा. So, sir, laminar flow is the flow where all the particles uh, follow a particular streamline path, and in turbulent flow, it can it does not follow a particular path line.
Okay, tell me the what is critical Reynolds number?
Sir, critical Reynolds number is a uh, is the Reynolds number when this laminar flow goes into the turbulent flow.
Is it so? Like
Yes, sir.
the
There can be a window of the transition flow also,
Hmm?
but after the transition flow, there will be the turbulent flow if the Reynolds number goes on increasing.
Okay, so tell me what is the value of what is the value of critical Reynolds number for flow over flat plate as well as for flow through pipe?
Sir, flow through pipe, for flow through pipe, it is if Reynolds number is below 2000, it will be the laminar flow. But if the flow will be is above 4000, it will be turbulent flow. But in the case of uh, this flow over the flat plate, I Mm, I think yes, sir. For that Reynolds number below 500 is the laminar flow,
Okay,
and
okay, okay.
Reynolds number
ठीक है, it's okay.
1000 is the turbulent flow.
Okay, and
Hello.
another question now I would like to ask. Could you please tell me what is the basic principle of surveying?
So, sir, surveying basically has two principles. First is working from whole to part, and second is that uh, each measurement mm, should be should be taken from at least 2 points.
I'm not able to hear you. Each measurement should be taken from.
Hello.
Could you please repeat after that? Yeah. Could you please
Each
repeat after
measurement
that?
each measurement should be taken from the 2 point of observations.
Okay, why not we work from part to whole?
So, sir, basically in whole to part, uh, it reduces the accumulation of error. But in the part to whole, we there is the accumulation of error, because in whole to part, first we set up the main points with higher accuracy, and then work on the part of the part of our project with in this of the part, uh, uh, and this will not lead to the action of errors.
Okay, fine. Good answer. Okay, that's all from my side.
Okay, sir. So we will be concluding Ashish's interview. So, sir, please provide him feedback so that he can improve himself. Yes, Ketan, sir. I'm audible to you. Uh, Sir, please start the feedback from starting itself. Yes.
Yes,
Yes,
sir.
sir, you're audible.
Hello.
Sir, you're audible. Please go on.
Ashish, I was just telling you few suggestions. Don't ever say no to some easy question, because unless until you feel that you are totally stuck there. Okay. Like for example, venturimeter or orifice meter were quite simple questions which you could answer. So maybe you can revise properly once, because you cannot tell directly no to those questions which you are learning since class 12th. So you might be learning fluid mechanics and these terms from class 12th as well. So you cannot just ignore them. Okay. And rest you are doing absolutely fine in courses like RCC, surveying, and so on. So you have a good knowledge of that. Your concepts are clear. So this was a little suggestion to revise those subjects in which you are feeling a little bit stuck. Rest you are doing well, and best wishes from my side. Okay. So if you have any questions, let me know.
सर बेसिकली फेवरेट सब्जेक्ट्स से रिगार्डिंग क्वेश्चन पूछे जा रहे थे, तो उसी लिए मैंने 3 सब्जेक्ट ज़्यादा प्रिपेयर किए थे, तो उसके दोनों फ्लूइड मैकेनिक्स थोड़ा वीक रहेगा, इन्वायरमेंट सर्वेइंग और RCC पर फोकस कर रहे हैं.
ठीक है, if they give you the option to ask from the favorite subjects, then that is fine. But if they don't give you the options, then you have to be ready beforehand as well, na? You cannot wait just for them to just let you ask the favorite subjects. Don't let them give an opportunity to ask. You should be confident over all the subjects. Okay, at least have some brief idea. So this venture meter and outreach meter was one of the easy questions. You could tell the difference. They may ask you to draw the diagrams as well. Okay.
आप कह सकते थे वहां पे
Yeah.
कि वेंचुरीमीटर एंड ओरिफाइस
डायग्राम
आर
लेना था,
डिफरेंट
उसका
डिफरेंट
बेसिक
बेस्ड ऑन देयर
रेफरेंस
डिजाइन।
पॉइंट्स थोड़े वो होंगे। क्या
यू आर
कैसे
नॉट
डिफरेंस
ऑडिबल
पॉइंट?
आशीष।
हेलो।
यस आशीष।
हाँ सर।
अब मैं
हाँ
कह रहा था आप वहां पे कह सकते थे कि ओरिफाइस मीटर एंड वेंचुरीमीटर आर बेसिकली देयर डिजाइन इज डिफरेंट। ओरिफाइस मीटर में होल होता है, वेंचुरीमीटर का जो डिजाइन होता है वो कुछ ऐसा डिजाइन होता है, डिजाइन के ऊपर में आप बोल सकते थे कि वो डिफरेंट है
हाँ
करके।
सर, वो
डिग
ऐसे होता है।
ऐसे केसेस आ गए,
होता है।
ऐसे केसेस आ गए ना तो सीधा क्या करना, मार्कर उठाना, बोर्ड पे जाना और सर मैं ड्रॉ द डायग्राम ऐसा बोलने का। इम्पैक्ट इंप्रेशन और अच्छा पड़ जाता है। ओके, और डायग्राम क्लियर बनाना। श्योर।
जी सर।
Okay,
ठीक।
so that was my side. So we will conclude your interview, Ashish. You are doing really good and बढ़िया चल रहा है आपका। I hope आपका सिलेक्शन होगा ही होगा, कंफर्म। Sure. Okay, so I'm stopping the recording.